The error detection actually brings to mind one of the more subtle bugs that we had in VMS version 1. And it's one of these classic examples of why code review is really a good thing to do. So early on, we're debugging VMS. We had, we were running on the VAX prototype. We were running a time-sharing system where people had terminals in their offices, and we were using VMS to develop itself. And just every once in a great while, the system would crash, and we'd look at the crash, and we'd discover that an instruction in the RMS code had been corrupted. And it was a case of like one bit had gotten changed. And so we were wondering, what in God's name is going on here? Because of course the code is all protected read-only, right? So it is not possible for a stray write to modify VMS code. And we were actually at the point where we were asking one of the VAX engineers, would you please take this? Oh, right. The other thing, by the way, was it was always this one place in RMS that got hit, and so we were actually at the point of asking one of the engineers, look, could you please take this memory board, take it out into the parking lot, and drive your car over it a couple of times, because we were absolutely convinced that this was bad memory. And then months later, one of our engineers was just reviewing some of the common I/O code in the VMS exec. And the routine in question was called IOC $apply ECC. So IOC stands for I/O common, a set of common support routines for all of the I/O operations. And the purpose of this routine was to handle a correctable error from the RPO6 disk. Now, this is back in the days of old dumb controllers that had essentially no buffering in them. So, nowadays, disk controllers have buffers. They pull the sector off the disk. They handle the buffer in their own memory, and then when they're happy with it, they transport. They send it over the I/O bus to the computer. Okay. With the RPO6, the bytes were actually sent to the VAX as they came streaming off of the disk, and it did not keep them in the controller. It was doing its ECC check as the bytes went by, and then when the transfer was complete, it would look at the result, and if it discovered that, oh, we had a correctable error in this sector, well, this has to be fixed. But of course the sector was no longer in the controller, and so what it did was it reported the error back to the driver and said, you have a correctable error, and then the driver would read out a couple of registers that indicated, okay, where in the sector is the error, and then here's the correction pattern to apply. Right? The driver would read those out of the controller, and then it would reach into the user buffer and apply the correction. Okay, now, right, so the problem now, it's not as simple as you think. The problem is that, of course, this buffer is part of the user address space. We're in an I/O completion interrupt routine, and now we have to reach into the user buffer. We don't have mapping for that. And so the way that was done was we allocated a system page table entry, and the driver would fabricate page table contents to map this user buffer, write it into that system PTE, and then reach through that piece of the system address space and apply the correction. Cool. Okay, what they forgot was that, right, on the VAX, the page size was 512 bytes and the I/O block size was 512 bytes. Now, if the buffer starts, say, 3/4 of the way through the user page, and the offset of the correction pattern is 3/4 of the way down the block, that correction is not going to be in the first user page. It's going to be in the next one. And whoever wrote that code forgot about that. And so the driver was making this offset computation, was loading the page table entry, making the offset computation, and then going one page too far in the system page table and using some other random pointer, some other random entry in the system page table to whack these bits, and that ended up accidentally whacking RMS instead. So that, among many other reasons, is why I'm a very big fan of code review, because the only way that you're going to find bugs like that is by reading the code. And it also leads to another principle of mine, which may sound a little egocentric, but it served me well, which is, if I don't understand the code, it probably doesn't work.